Hello friends, welcome back to the channels and tutorials. I am your sir here to guide you with the remaining classes. Now let's go straight to the point. Exercise 10.2. The last videos, what have we done? Last videos we have done some problems on some of the theorems, right? Some problems on some of the theorems, and so this will be the third video, yeah, third video on the chapter circles. So if you have not gone through the first two videos, please go through the first two videos. That's really going to be very helpful for you. So I hope all of you are doing well and staying safe at home. Okay, without much ado, let's get straight to the point. That is exercise 10.2. So remember this question number 4 from the textbook of the NCERT Mathematics class 10. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. Remember this activity? Actually, we proved this using one activity in the first video. So if you're still unaware of that activity, that's why please check the first video. You will come across that activity. So getting back to the question, prove that the tangents drawn at the ends of a diameter of a circle are parallel. So let's draw a circle. Let's draw a circle. Okay, this one looks a little bit. So now, of course, I cannot draw perfect circles. So if I draw this circle, then what? Prove that a tangent is drawn at the ends of the diameter of a circle. So for that, we will have to draw a diameter, center O. So proof, let us assume a circle with center O. Let us assume a circle with center O and diameter AOB. So let's name the diameters A, O, B. Done? Now what they're asking is, okay, I hope you've written it down because I have to draw the figure, so I'll have to rub this part off. So prove that the tangents drawn at the ends of a diameter of a circle are parallel. So done? I'm rubbing it off, okay? So these are the endpoints of the diameter. So what I have to do is, okay, I will draw. Of course, we have proved this through our activity. Now let's see how do we prove this mathematically. Okay. So let's name this like P, Q. Let's name this as X, Y. So let us just name PQ and XY be the two tangents at A and B respectively. Done? Okay. Now what are we supposed to prove? We're supposed to prove, PQ is parallel to XY. That's what the question says, isn't it? Prove that the tangents drawn at the ends of a diameter are parallel. Right, that's what we have to prove. Chalo, I hope you're done. Okay, I'm rubbing it off. Of course, you can pause the video and note it down. Proof. Okay, how shall we prove? How are we supposed to prove this particular theorem? Now, theorem. We are supposed to prove that PQ is parallel to XY. So how do we generally prove the lines are parallel? How do we generally prove that the lines are parallel? Now there are many ways to prove that lines are parallel, isn't it? Some of the basic things would be how do we prove lines are parallel? See, I hope you have the concept of alternate angles, corresponding angles, isn't it? And Euclid's theorem, Euclid's theorems and all. So as we know that alternate angles, alternate interior or exterior angles, corresponding angles, these are only possible for parallel lines, isn't it? If the lines are not parallel, then the alternate interior angles or exterior angles, the corresponding angles, actually they are not supposed to be equal. Or there's another one that the sum of the angles, interior angles on the same side of a transversal, of course, if it is also 180 degree, then by Euclid's theorem, then we can prove that the lines are parallel. So many many ways to prove that the lines are parallel. Okay, so let's try this with the alternate interior angle theorem. Okay, so now let's see what we do. Of course, I'll tell you, it's like, if for those who might have slightly forgotten, if there are two lines and the transversal cuts through those two lines, then there's a group of interior angles that is being formed. 1, 2, 3, 4. If and so if it happens, like if angle 1 is equal to angle 3, alternate ho gaya na? If angle 1 is equal to angle 3 and 2 is equal to 4, then we say that 1 and 3 are equal, alternate interior angles. 2 and 4 are equal, alternate interior angles. That is possible only when these two lines are parallel. So we're going to do something like that. Okay, we're going to be proving like that. Now, chalo, let's write down. We know that tangent. We know that tangent is perpendicular. We know that tangent is perpendicular to radius through the point of contact. So in that case, what happens is OA is perpendicular to PQ, OB becomes perpendicular to XY, isn't it? Right, I'm going to rub off the question now. Okay, we do not need that question now anymore. Okay, so to prove, I'm rubbing it off. Okay, chalo. So OA is perpendicular to PQ, OB is perpendicular to XY. So now, see, that means 90 ho gaya, ye bhi 90 ho gaya, 90, 90, 90, 90, isn't it? Now, if you are planning to prove using alternate interior angles theorem, if you're planning to use Euclid's theorems, no problem. I'm planning to use here alternate interior angles. So I will just mention only the angles which I need. Okay, I'll mention all the angles which I'm going to need. So in that case, angle PAO, kahan likh diya AAO, PAO, or okay, let's go from the reverse. OAP 90. Let's mark this as equation 1. Angle OBY 90, equation 2. So 90, 90. Now you see both of them are equal, isn't it? Equal, equal, alternate. So angle OAP is equal to angle OAP, OBY, OBY. But they are alternate, but they are ALTERNATE, but they are alternate interior angles. So PQ parallel to XY. Bus. I'll give you the other way. You can even take these two angles, 90, 90. Now add these two angles, 180. So by Euclid's algorithm, sum of the, not algorithm, Euclid's theorem, sum of the angles on the same side of a transversal, if it's supplementary, I mean if it's 180 degree, then the two lines are parallel. That way also you can prove. Simple as that, right? Sure. Done? Okay. Let's move to the next question. Next question is a very simple but a tricky question. Okay, next question is a very simple but a slightly tricky question. That is, the question says, let's please write down the question. As I was saying in the previous video, sometimes what happens is we only study the solutions. So exam mein what happens? Solution तो याद है लेकिन क्वेश्चन याद नहीं होता है. So question is also very important. The question again, prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay, this is one question. Prove that the perpendicular at the point of contact to the tangent to a circle. Prove that the perpendicular at the point of contact. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Chalo. How do we prove this? It's very simple. We are going to be just using, okay, I'll get straight to the point. See, there are some theorems which we already know. This is also something which we already know, but we have to prove it now. Okay, for that, let's think of some theorems, how we are going to prove. Universal facts. See, ek baat to tay hai. One thing is for sure, that is, if I have a circle now, and there is a tangent, then what happens is, when I draw a perpendicular to this tangent at the point of contact with the circle, as per theorem, it states that it is going to be perpendicular, and then what happens is it is going to be passing through the center because that perpendicular happens to be the radius. You got that point? Tangent, because tangent at any point of a circle is perpendicular to the radius through the point of contact. So if I draw a perpendicular, right, if I draw just a perpendicular line, so if I just assume this to be the tangent L, I draw a perpendicular line M, this is P, point of contact, then what happens is, when I just do this, then it is said that tangent is perpendicular to the radius through the point of contact, and that's it, no? Another thing is, radius will always pass through the center, isn't it? Right, radius will always pass through the center. So what is our question here? Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Ho gaya na proof? Perpendicular, tangent, they are perpendicular to each other, because whenever you draw a perpendicular to a tangent at the point of contact, it is going to be perpendicular to the radius through the point of contact. That's one theorem that we know. And radius will always pass through the center of a circle. So that's another theorem that we know. So when you combine these two theorems, what happens? Definitely that perpendicular jo draw kiya tha, that perpendicular that you drew was the radius, right? Because it can only be the radius. And radius is always passing to the center. So there we have it. That's our proof. So it seems like, okay, kaise proof karna isko, but it's quite simple, no? There are other ways also. We take imaginary lines yahan se, and then prove that, okay, those two imaginary lines are actually the same, passing to the center. It can get as simple as this, isn't it? Just use 1 or 2, 3 theorems. Bas ho gaya na. So let's write down. Let's go for the proof straight up. So we can write down by theorem. Because para hua hai na, already studied. By theorem, tangent at any point of a circle. By theorem, tangent at any point of a circle. Tangent at any point of a circle is perpendicular. Is perpendicular to the radius. To the radius through the point, I'll just write here, of contact. So please write it down. Figure also please draw. Okay, in the meantime, I will wrap the question. Exercise सबको पता है ना अभी. Now we are doing exercise 10.2. No, so rubbing it off. So by theorem, we know tangent at any point of a circle is perpendicular to the radius through the point of contact. And radius, right, and radius will always pass through the center of the circle. And radius, universal factually, will always pass through the center of a circle. So this explanation actually is enough, but I'll just give you a little bit more. So what we do is we draw M perpendicular to tangent L. Okay, we draw M perpendicular to tangent L. I'm going to rub so tangent, we draw M, no, that perpendicular line to a tangent. We draw M perpendicular to tangent L, which will pass through center of circle, which will pass through center of circle. Why? We've already proved, no, that is going to pass through the center of the circle. Also, OP perpendicular to L, right? Also, OP perpendicular to L as radius. Also, OP perpendicular to L as radius is perpendicular to tangent. As radius is perpendicular to tangent. Actually, you know that up to here also, if you write, if it's just for 1 or 2 marks, up to here also, if you write and then you just conclude like hence tangent perpendicular drawn to a tangent to the point of contact passes to the center, even that will also do actually. Okay, like this is also not needed exactly, but okay, just if you want to elaborate more, that's why I'm just doing this. OP perpendicular to L as radius is perpendicular to tangent through OUH through point of contact, through point of contact. So OP and M. So OP and M. So OP and M actually coincides. So OP and M actually coincides. Hence, perpendicular OP, hence perpendicular OP of tangent L, hence perpendicular OP of tangent L passes through the center. Plus, that's it. Actually, as I say, if it's just for 1 mark or 2 marks, okay, that first part of the explanation should be enough. But if you want to elaborate a little bit more, elaborate that a little bit more for you. Okay. Let's go quickly to one question again. The next question is number 6. That is the length of a tangent. The length of a tangent from a point A. The length of a tangent from a point A. Distance. Distance 5 centimeter from the center. From the center of the circle. Is 4 centimeter. Find the radius of the circle. Okay. Chalo. The length of a tangent from the point A. at a distance 5 centimeter from the center. The length of the tangent from point A, which is at a distance of 5 centimeter from the center. Which is at a distance of 5 centimeter. This point A is at a distance of 5 centimeter from the center of the circle is 4 centimeters. So suppose if this was the tangent, P. So this is 4 centimeter. Find the radius of the circle. So last theorem also we just did that. No? Point of contact, center, draw, radius. Okay, no? This one we know. Actually, in one of the MCQ questions in the last video, we solved a question similar to this. So I'm going to quickly brush through this. So tangent, right angle triangle, Pythagoras theorem use karo. Chalo. I'll just go for solution. That is, we know. Yeah, tangent perpendicular to radius through point of contact. Please don't mind my handwriting because maths teacher ho na, so handwriting a little bit tera-mera. THR, no? Through point of contact. So handwriting not very good, okay? Please adjust. Let AP be the tangent. Let AB be the tangent to the circle with center O at point P. So radius is OP. So radius is OP. Therefore, what happens is OP perpendicular to AP. So in right triangle AOP, in right triangle AOP, what happens? No, we know one more thing, that is any side which is just opposite to that 90 degree is the hypotenuse, isn't it? Last video I told you like which one to take on the left hand side, which one to take on the right hand side for easier calculations, no, so that we don't like mess up things. So in that case, this square plus this square will be equal to this square, isn't it? So I'm going to write it that way because I have to find out OP, no? So OP square plus AP square is equal to OA square. Dekha na thik? OP square AP square OA square. Pi, if you have to write down, you can just write Pythagoras theorem, no? By Pythagoras theorem. So B square plus AP square 4 centimeter. Let's write down the units also. 4 centimeter square 5 centimeter square OA, no? OA 5 centimeter, isn't it? OA 5 centimeter. So OP square plus 16 centimeter square 25 centimeter square. So OP square equal to 25 centimeter square minus 16 centimeter square is equal to 9 centimeter square. इसको रफ करता हूँ फटाफट. So OP will be square root of 9 centimeter square. So that's going to be 3 centimeter. I already mentioned before also that when we take units of length is never negative, it is always positive. So when you go for square root of numbers, we generally ignore the negative value. We only go for the positive values because we are going for length. Length is never negative. Okay, so yeah, that's it. That's like 3 centimeter. So I'm going to wind up here for today. In the next video, I will be doing more questions sequentially. So if you have liked this video, at the end of this video, please hit the like button and please do subscribe and share it with maximum of your friends who cannot attend classes and even those who attend classes. Thank you.